Good afternoon and welcome to our crop production seminar. And today we're going to be specifically talking about aeration and controlling the climate within your grain bin. My name is Derek Johnson. I'm the sales manager for GrainGuard, which is a division of AgGrowth International based out of Western Canada. Like I said, today we're going to talk specifically of creating that perfect climate inside the storage bin that you have for your grain. And through adverse weather conditions, how do you control that climate inside your bin? Well, number one specifically is controlling the grain temperature level. Very important to control what you can do as far as grain temperature inside the bin. Number two, controlling the moisture level. Again, another key component for creating that perfect climate inside the grain bin. And number three, providing consistent airflow through that stored grain so that we can provide a great condition for that crop to be stored in. Depending on the time of harvest and the circumstances surrounding harvest, a grain crop may have to be stored on farm before it can be marketed, whether it's commercially or for seed purposes. The quality of the stored grain will deteriorate unless low moisture levels and low temperature levels are maintained. Insects, bugs, mites, molds, different funguses will occur and spoil that grain if it is too warm or too moist. Effective conditioning of stored grain then prevents that spread of insects and other damaging organisms that may inhibit the quality of the grain. So therefore, effective conditioning actually preserves the quality of the grain in the bin. There's a couple key definitions that we need to look at when we're talking about aeration. One is airflow, and understanding exactly what airflow is. Airflow is measured in cubic feet per minute through a bushel of grain. And remember that air always takes the path of least resistance. So airflow is actually the amount of air that's moving through that cubic foot of grain. What is static pressure? Another important definition that we need to understand in order to properly understand aeration. Static pressure is a measure of the amount of air that a fan must provide in order to force air through stored grain. It's measured in the inches of water column. Really, to understand this, we need to know that the height, and as the height of the grain increases, so does the static pressure. As well, the type of crop and moisture content will affect that static pressure inside the bin. A couple other definitions that we need to look at is the difference between aeration and drying. Aeration involves a low volume of airflow, and that's really where we're talking about 0.1 CFM per bushel. Drying, on the other hand, involves a high volume of airflow, beginning at 0.75 to 1 CFM per bushel. Aeration is mainly focused on cooling the grain and allowing for a longer safe storage period, whereas drying, and for drying to begin, stored grain needs to be 10 degrees Celsius, 50 degrees Fahrenheit, or higher before that grain will release moisture into the moving air. Aeration is really geared towards cooling grain and preventing insect activity. Drying, on the other hand, has all the benefits of aeration, only faster. Some of the characteristics of aeration, because of the low volume of airflow that's used, and remember we said it starts at 0.1 CFM per bushel, the distribution of air is less uniform. While some of the moisture may be redistributed or removed from the grain during the process, aeration cannot be relied on as a drying system. Now, even though grain may be harvested dry, in some cases, if it comes in too hot, it's important to ensure that that grain is cooled down. When grain is not cooled, it can heat, which can lead to more spoiled grain or a greater insect infestation. Understanding how airflow moves in a grain bin is also very important to understanding how to properly condition your grain. Remember that airflow always takes the path of least resistance. And the aeration fan that you do have on the outside of your bin is that source of airflow for the bin. In order to properly aerate stored grain, there's got to be a conduit that distributes that airflow generated by the fan throughout the rest of the bin. Some of the benefits of aeration and proper grain storage is really understanding the fact that aeration is primarily aimed at temperature control to prevent grain spoilage. This will allow higher moisture grain to be stored safely until it is convenient to be dried, even well after harvest has been completed in some cases. The real main benefit that we're looking at here for the farmer is flexibility and providing the farmer flexibility at harvest time. When we're looking specifically at canola for aeration, the whole concept is that the aeration fan should be started as soon as the grain covers the aeration system, that whatever configuration is inside that bin. This is very important so that the cooling of the grain and the cooling of the canola can start as soon as possible. Airflow rates for aerating canola should be at 0.1 to 0.15 CFM per bushel, which is 1 to 2 liters per second per cubic meter. At the lower end of this range, it may take up to 200 hours of full fan operation to cool the grain in the bin. If this airflow rate is increased, then it's obviously going to be able to achieve this in a fraction of the time. Once the fan is started, and this is a real key, once the fan is started, it must be kept running until the temperature of the seed or the grain in the bin is close to or just slightly above the temperature of the outside air. When we look at safe storage time, and the chart that it shows here, safe storage time in days of cereal grains, you can see that as the temperature increases, so as we get down to the lower end of the grain temperature chart on the left-hand side, and as the moisture content increases, the number of safe storage days goes down. So, for example, looking at a grain temperature of 25 degrees Celsius and a moisture content of 20%, we're looking right around 5 to 8 days of safe storage time for cereal grains. On the other hand, when we look at canola, again, the same trend holds true. As the initial seed moisture increases and the initial seed temperature increases, we start to see fewer days of safe storage. Now let's shift gears and talk a little bit about natural air grain drying. Smaller size kernels, and when we talk about drying down that crop, the smaller size kernels require higher volumes of air than larger size kernels. And again, that goes back to our whole idea of air taking the path of least resistance. Smaller size kernels are packed closer tightly together and airflow is restricted. Typically cereal grains such as wheat and barley are going to require 0.75 to 1 CFM per bushel to dry. Oilseeds, on the other hand, such as canola and flax, require 1 to 2 CFM per bushel to dry. Again, making sense, the smaller seeded crops require more airflow to dry them down. As the air travels through the grain in the bin and through that stored component, it picks up moisture and forms what we call a drying front. The drying front is generally 8 to 12 inches thick and is the wettest grain in the bin. The grain below it is dry. Now, if we look on this slide, what we see is the drying front occurring in the middle of the bin, the dry grain on the bottom of the bin, and that drying front continually moves up through the bin. And if the fan is stopped at any time, that drying front will stall. And if it's left with air for too long, that high moisture area and that high densely packed grain will heat and form a mass and deteriorate in quality inside the bin. When we talk specifically about natural air drying for canola, the fans should be started again as soon as the seed covers the aeration system inside the bin. That fan should be turned on. The drying process needs to start as soon as possible to keep that seed from deteriorating. Airflow rates for natural air drying should be in that range of 1 to 1.5 CFM per bushel, which is 12 to 18 liters per second per cubic meter. Drying rates are going to vary with the ambient temperature and the ambient conditions that are present, but under ideal conditions, which would be a temperature of 10 degrees Celsius with low relative humidity and sufficient airflow, it may be possible to achieve 0.25% to 1/3% daily crop or daily moisture percentage drop inside the bin on that canola crop that you've got stored. Here again, the experience has shown us it is best to run the fans continuously until the drying front has moved up through the bin, out through the top of the grain, through the ventilation system, and the top of the bin. And of course, with that also, we strongly recommend that the grower does not shut off the fan during periods of high relative humidity. Even though we may be adding some humidity to the bin, we want to make sure that that drying front, which is much more wet than the air that would be coming in, is moving up through the bin and out the top through the ventilation system. As we mentioned, ventilation is very key. Roof and wall vents are very important on all bins used for aeration or drying, as they are a means for exhausting that moist air. The air that is exiting the bin is carrying that moisture, and it needs to be removed from the grain. Our general rule of thumb on roof vents and wall vents is 1 square foot of opening for every 1,000 CFM that the fan is pushing out through the grain. When looking at creating an aeration system for your farm, you need to know how to choose the correct fan. Choosing the correct fan involves several key points. When we look at a general rule of thumb, we always use 1 horsepower per 1,000 bushels for your fan, up to 500 bushels of the maximum. So an example of this would be a 3 horsepower fan would do up to 2,500 bushels. Second point, know what application that the fan is being used for. Is it being used for aeration or is it being used for drying? This will help determine the style of the fan. We'll get into that a little more in a few minutes here. Also, know what crop is most likely to be stored in the bin. Canola requires more air than wheat, and wheat requires more air than peas. So again, the smaller seeded crops require more airflow and a larger horsepower fan than the larger seeded crops. A fan that is sized correctly for drying will always be able to properly aerate a bin. However, a fan that is sized only for aeration cannot be relied on for drying. And that's a very key point to consider when choosing the right fan for your bin. As I mentioned, there are several different types of fans. We're going to talk about 4 of them in our system, and 2 of them specifically here are inline and high-speed centrifugal. Inline centrifugal fans are ideal for low to medium static pressure. They're great for aeration on bins, and they're capable of drying in some capacity cereal grains. But they have limited drying ability when static pressures are greater than 5 to 6 inches. So an inline fan is really great to use in more coarse seeded crops where we're looking at aeration applications only and potentially a wider, shorter bin. High-speed centrifugal, on the other hand, are ideal for medium to high static pressure. They have the ability to aerate bins quite easily based on the high speed of airflow that is pushed through. A high-speed centrifugal fan provides enough airflow to dry the grain quickly and efficiently. And it also handles the static pressure of small seeded crops. So when we look at crops like canola and flax, for instance, a high-speed fan is critical for the success in your aeration system. 2 other fans that we do provide are the low-speed and the axial fans. A low-speed fan is a much larger unit, and these fans are to be used specifically with coarse and cereal grains. They are the highest air output, and that really allows them to aerate and dry down large seeded crops like corn and soybeans, and aerating large cereal storage bins. They are to be used in situations where static pressures are 7 inches or less. An axial fan is like a junior version of a low-speed fan. These fans are to be used only where minimum airflow is required. They are typically used with corn or coarse-seeded crops like beans, and really to be used in situations where we're seeing much low static pressures, right around 4 inches or so. Along with your fan and your aeration system, you can add a low temperature heater or a supplemental heat source for helping to dry the grain down. A couple of the benefits of adding supplemental heat are you are extending the drying day and you're extending that growing season, that season where you've got your grain stored in the bin, by raising the temperature 10 to 12 degrees Celsius. And really what you're doing here as well is increasing the ambient temperature. And by doing that, increasing it 10 degrees Celsius or so, you're going to help reduce the relative humidity up to 15%. High relative humidity and low temperatures are the greatest inhibitors of grain drying. So if we can help increase that temperature and decrease that relative humidity, we're going to help bring down the moisture content in the grain. A couple different aeration systems that can be used in hopper bottom scenarios. The rocket aeration system is a vertical aeration setup. Essentially is considered a permanent installation inside the bin and is really effective for conditioning and drying grain, specifically through that core area of the bin where the air is hardest to move. Again, the design of the rocket allows it to push air up through the center of the bin and focus on that core drying front where the air is most difficult to move and where spoilage most readily occurs. A horizontal tube aeration system is like it says, a horizontal system that can be a permanent or a temporary system. It's very effective in conditioning the grain and does a good job of aerating through the outward diameter of the bin. However, it cannot be relied on for penetrating that core of the bin where air is hardest to move. The rocket system and the rocket aeration system really acts as a conduit to help distribute airflow from the fan through the rest of the bin. And as we mentioned before, this creates that drying front, that 8 to 12 inches of the wettest part of the bin that moves up from the bottom of the bin through the top and keeps moving as long as that fan is running on the outside of the bin. Like a rocket system, a horizontal tube acts as a distributor of airflow from the fan, generated from the fan, throughout the bin. The one benefit of the horizontal tube system is that it can be easily removed from the bin if the farmer requires to use that bin for storage of non-grain products like fertilizer. So the scenario has come up that if you have an existing hopper bin without aeration in it, and you're looking to install an aeration system similar to the rocket that forces air up through the core of the bin, what are your options? GrainGuard has come to the market with the Retro Rocket. It's an easy do-it-yourself installation of a retrofitted unit that can fit in through the manhole of the hopper bin and can be installed quickly and easily. It's really an effective system, again, that can be retrofitted into existing smooth wall or bolt together hopper bottom bins. The real advantage of the Retro Rocket is, again, just like its parent, the Rocket, it's forcing air up through the grain core of the bin and creating that drying front that moves from the bottom to the top of the bin. The Retro Rocket itself comes in a folded down unit that can be inserted in through the manhole, and once set up into position, the Retro Rocket just continues to unfold, 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 and can be bolted down inside the cone with very little work. We've had a couple of crews install these Retro Rockets already this year, and the first one took roughly about an hour. The second Retro Rocket was installed in less than half an hour. So again, a very simple aeration system to retrofit an existing hopper bin. For over 20 years, GrainGuard has been providing aeration fans and solutions to farmers in Western Canada and around the world. In that time, our brands have become the most widely recognized provider of aeration solutions, trusted through our consistent, value-added performance. Thank you for your time today, and we hope that we have been able to help you decide on creating the perfect climate for your bin.